Okay, it says we're recording. Ask that question again.
Yeah, so I was just curious if the test is coming up and we look back on our quizzes and we see that we're doing like really good or really bad. Is that going to be like a good indicator of what to expect on the test? Are the questions similar and things like that?
So it's always a good idea to study your quizzes. The difference is I try to do a lot more multiple choice on the quizzes. I know some people prefer multiple choice, whereas on the test you're probably going to be more show your work. So it's good and bad. I don't want you to think like, oh yeah, I aced all the quizzes, I'll ace all the tests. I could put a quiz question on a test. It won't be on purpose necessarily, but and there will be some multiple choice, but the tests are going to be a lot more show your work than the quizzes. The quizzes I do multiple choice just so I don't have to grade them, and there will be a lot more show your work. So if you're looking for hints, there probably won't be as many hints on the test.
Okay, cool. Thank you.
Okay.
So for this first test, since it's more show your work, there's probably not going to be a lot of vocabulary. Just like we have to understand what it is to answer the questions, kind of thing. I'm assuming.
So what's your exact question?
Well, like, so you're saying that we're going to do more show your work. So like as far as vocabulary goes, we're probably not going to have to write down.
So vocabulary probably will be more multiple choice. So chapter 1 probably will be more multiple choice. Chapter 2 will be more make a graph, create a frequency distribution. In fact, normally, I was looking at my old quizzes. Normally I say, make a frequency distribution, but I didn't want to grade it, and so that's why there were only 2 questions. It was a very short quiz, I'm sure you know, because it's hard. It's hard to find multiple choice for that. And so, yeah, so chapter 2 is going to be a lot more show your work. Chapter 1 is probably be a lot more multiple choice. But even with chapter 1, I might give you a scenario and say, what's the population? What's the sample? And it probably won't be multiple choice either. So does that answer your question?
Yeah.
So I'm going to plan on, I think Monday is Labor Day. So as far as the test next week, so Monday we'll have off. Tuesday we'll probably cover one more section, whatever section that is. Wednesday we'll have a review. So you'll have your quiz due on Wednesday just like normal, but we'll just have a review. There won't be any homework due Thursday, and that will be your test day. So we'll plan on a test next week, especially since it's kind of a short week. So any other questions? All righty then. Okay, so just peeking here, how many people we got here? So we got 23. And I just wish I knew people's names better and faces and masks. I'm going to try the together mode and see if that works any better.
You can also do like the large gallery mode, and that would still show people's names.
Oh, it will?
Uh-huh.
Oh, it's the names that I really need. Let's try gallery mode. Well, that's what we have, but that doesn't show everybody.
You can do the large gallery, and it will show more people. It still won't show everybody.
Oh, large gallery.
Yeah, there should be a way where you can see everyone like you're seeing us now, but the whole class.
Oh, that's a lot better. Okay, cool. All righty then. Okay, so let's somebody asked me yesterday because they weren't in class to see my notes, and I'm like, my notes aren't really very good. You can see my notes here. Believe it or not, we're gonna cover all this. My notes aren't very useful. But anyway, we're going to talk about organizing quantitative data. So what I'm going to do here is I'm going to pull up another spreadsheet.
So is today, are we going over like 2.2 and 2.3 more?
Yeah. So we're going to get into the good stuff here, if I can find my worksheets here. Okay, worksheet 2.2. Okay, so we're going to talk about histograms. Now, a histogram is like a bar chart, but, and here there's a few big buts here. So number one, it's used on numeric data or quantitative data. You must group the data yourself. You must have equal sized groups that don't overlap. And number four, the bars must touch. Okay. Okay, so we've got a bunch of data here. So these are the number of lunch arrivals at Wendy's restaurant during every 15 minutes. So the first thing I'm going to do is I'm going to put everything in a single column because it'll make it easier. Now realize you're going to have to do all this by hand. One of the nice things about using Excel is I can sort really easily. So you can see that this goes from 1 to 11. Okay. Now, whenever we're doing numeric data, you might want to go 1 to 5 and 5 to 10 and 10 to 15. Whoops. 5 to 10. Okay, but the problem is, and I'm not going to do this right now. If you get a 5, does it go in group 1 or group 2? And if you get group 10, if you get a 10, does that go in group 10 or group 15? Okay. And so the idea here is we don't want to overlap, and we do want, and by the way, this first group is only 4, and the second group is 5, and the third group is 5. So these are not equally sized. Okay. So whenever we're doing something like this, we need to make sure that they're equally sized and they don't overlap. Okay. Now I'll give you a couple more rules here. I'm not going to give you large data sets. So this is probably as large as I'll give you, and it's got about 40 in it. Okay. So I'm not going to give you several hundred pieces of data. If I gave you several hundred pieces of data, you wouldn't have to live by this rule. But so I'm going to say use 5 to 7 categories because I'm going to give you some small data sets. Now, if you're using several hundred pieces of data, you're going to use more than 5 to 7. But for the data that we're going to be using, we're going to keep it pretty small. So the idea here is I've got 1 through 11. So if I go, let's do 1s and 2s. I have to be careful because if I put 3 to 4, it thinks it's March 4th. But anyway, 3 to 4, or maybe here, I'm going to do it this way. Okay, so the idea here is we're still going to make a frequency and relative frequency table. So the idea here is I'm going to make my groups here. So these are 1 to 2 customers, 1 to 2, and then we're going to do 3 to 4, and then we're going to do not 4 to 5, 5 to 6, and 7 to 8, and 9 to 10. And then you'll notice I don't have a 12. But I'm going to still make this group 11 to 12 because I want all the groups to be equally sized. Okay, even though there's no 12s, I'm going to call it 11 to 12. Okay, now you'll notice here I've got 6 groups, so that's about perfect. And then I'm going I'm going to have, let's pick on somebody here, such as Sarah Larson. Can you tell me, Sarah, how to make a frequency distribution?
So you would write down how many times there's a 1 or a 2. So it looks
Okay.
like 1, 2, 3, 4, 5, 6, 7. Would be the
See,
frequency.
this is where you're going to wish that you had Excel, because down here, if you look here, it says there's
Oh,
7
nice.
right there. You don't even need to count. Okay. So yeah, so you exactly right. You're just going to count up the 3s and the 4s. In this case, it has 5, 5s and 6s. Ooh, we got a bunch of those. We got 18 of those. 7 and 8. We've got 7 of those. 9s and 10s. We only got 2 of those. And 11 and 12. We've only got 1 of those. Okay. So good job, Sarah. Now let's see how smart you guys are. Can somebody else, such as Rayleigh Anderson, can you tell me how to make a relative frequency distribution?
Relative. Huh. I don't know.
Oh, that was yesterday's homework. You're supposed to remember that.
Dang it.
Okay.
Sorry.
Oh, you're not on camera either, Rayleigh. Where's your camera?
I emailed you about that yesterday, that it's
Oh, you
broken.
did?
I'm trying to figure it out.
Oh, okay. Yeah, call the help desk. They can probably help you figure that out. They're really good on stuff like that. How about Paul? Paul, can you bail out Rayleigh?
No.
No.
No, I wasn't able to figure that out.
See, yesterday's quiz was way too easy because I wanted to say figure out a frequency and relative frequency, and so far only Sarah would have passed. How about Mia? Mia, are you on mute?
Sorry, forgot to hit the button. You have to total the frequencies and then divide the frequency by the total.
Exactly right. So we're going to find the total first. We've got 40 lunchtime counts or whatever. And then we're going to take the 7 and we're going to divide it by the 40. And that's going to give us the percent. So 17.5% of the time we had 1 to 2 people. Okay, does that make sense? Rayleigh and Paul?
Yeah, that makes sense.
Are
Yeah.
you ever going to miss that question, or are you going to nail that on the test?
I'll nail it.
Yeah,
Okay. Okay. So you learned something today, although you should have learned it yesterday. Here, I'm going to copy this formula down. And so now we have a nice relative frequency distribution, okay? Now, I'm going to show you guys. Now, you guys are going to have to do this by hand. But the idea, normally I would show you guys how to do this on the computer, and I think it looks better on the computer. I'm going to insert. Now, by the way, I will warn you, there is a histogram maker right here, okay? Don't ever use it. It sucks, especially on this test. But anyway, so I've got my own groups. So the first thing you have to do is you got to make your groups, and then you got to make your frequencies. Now, I'm going to do a relative frequency, I'm going to do a frequency histogram, okay? So I'm going to, in this case, I'm going to create a bar chart just like that. Now, you'll notice it says there the bars must touch, okay? And they're not touching, but if I change my layout to here, now my bars touch, okay? Now, it's important, especially when you're doing something like this, that we put the number of customers down here, and we put count or frequency, okay? And then for your title, you can say number of lunch arrivals every 15 minutes at Wendy's. Okay. So, biggest mistakes that I will see on the test is improper labeling of your histogram. So that's, well, not only that, but a lot of people will just go, oh, I'm going to just make a histogram like this, and they're going to go insert, and they're going to make a bar graph out of it, and then they're going to make the bars touch. What happened? Where's my quick layout? There it is. And I've even seen people do this. Why is this not a histogram, even if it's properly labeled?
Because it's not in groups.
It's not grouped.
Groups. It's yeah.
Yeah, exactly right. Okay. So make sure you must group the data. That's the big thing yourself. Okay, and they must be equal size groups that don't overlap. Okay. Now the idea with a histogram is we hope that the data, the graph, maybe I'll just call it the histogram looks like a bell curve. Would you say that our data is a bell curve? Pick on McKay. What do you think?
Yes, I would say so.
Kind of, sort of. You could get away with it a little bit. Okay. Now I'm going to talk about different types of data, and I'm going to draw different types of curves. So if you have something that looks like this, obviously that's what we would call a bell curve. Okay, we love our data. This would mean it's normally distributed. We're going to talk about our normal distribution. Okay. We could also say our bell curve is symmetric. Okay. And that's what we hope that our data looks like, because it's the most common. It's the most common, but it doesn't mean just because it's the most common that we will always get it. Okay. Sometimes we will get some curves that look like this, or they will look like, maybe I'll try these side by side, a mirror image of that. Okay. Now, the idea here is if I were to draw a line at the peak on both of these curves, okay, this is where people get mixed up. Do you see that in this case, my right tail is a lot bigger than my left tail? So this would be an example of what we would call right skewed, okay? And this in this case, the left tail. So this is going to be left skewed, okay? So those are two other types of curves that you will often see. We will also see something where maybe you've got two humps, okay? And this is what we will call bimodal. Or you could even see three humps, something like that. And this is a case that we would call trimodal. And when we get into chapter 3, I think you'll understand better why we call those modal. But anyway, you'll also see, hopefully, I'm going to draw it like this. If this is, ooh, that's a terrible line. You also may see something that looks like a big square, okay, or a rectangle, I should say. And this is what we would call a uniform distribution, okay? So this would be an example of random numbers. You would expect random numbers to form kind of a rectangle, okay? That would show that they're random. And so on the test, you'll get a graph that may look something like this. Now that you know all the choices, maybe I'll put the choices here side by side. Oh, geez, I can't quite make those on the same. Here, let's slide this over a little bit. Okay. So perhaps kind of bell curvy. You could maybe say this is probably has a little bit of a right tail that's a little longer. So maybe right skewed. You could also argue that it's bimodal because you kind of have two peaks.
So can I ask a quick question about the bimodal and trimodal?
Okay.
So, I mean, the way you drew it is the peaks are like ascending in height. Does it have to be that way, or I mean, is it just
no.
3 peaks? Okay.
Yeah, they could. This peak could be high. Yeah, whatever. It can be anything.
Okay.
And you could even get something that doesn't look like anything I've drawn. But these are the main shapes that we're hoping for. So any other questions? And of course, I drew these with nice curves, but they'll probably be more boxy. Okay. So let's see. So we've oh, and the other thing is, I do want to just point out here, you guys don't need to know how to do this in Excel, but if I asked you to do a relative frequency histogram, then I'm going to use these two columns to draw my graph here. And I'll make the bars touch. You'll notice basically, maybe I'll do it this way, okay? These are basically identical curves. The main difference is instead of having a count here on the right, I've got percent here. Okay, and I would still have the number of customers down here. And I would still give me the number of lunch arrivals at Wendy's every 15 minutes. Okay. So the main difference is if I ask for a relative frequency histogram, I'm looking for percent. If I'm asking for a frequency histogram, I'm looking for the counts. In either case, the basic shape of your graph is going to be identical. So you can kind of see that there. Okay. So does that make sense?
Yes, it does.
Okay. All right, so let's see if you guys can do it again. I'm going to put this all in a single column here. This is what we're going to call a continuous. Now, by the way, in my tabs here, I've got discrete and continuous. Okay, that was last week's lecture. We're going to see who knows what's the difference between discrete and continuous. Matthew, how do you say your last name?
My last name is pronounced Ianziti. It's Italian. You can say it like the letters E, N, Z, and T in quick succession.
Okay, all right.
Explained it a lot.
That's the spicy meatball. All right. I don't know if you remember that commercial. Okay, so Matthew, what's the difference between discrete and continuous? Do you remember?
Yes, sir. Something that is discrete is something that's countable.
Okay,
like you can have a certain number of people in a room, but you can't have a fraction of people in a room. Whereas continuous is something that you can have decimals or fractions with, like temperature or distance, things like that.
Perfect. Okay, so I'm going to sort this right off the bat because it's going to be easier. Now, let me just mention here, you do not need to sort your data. And I will tell you this, even though you'll never use this. You can create a histogram with this thing. This is also, but I just don't like to use it because I think it sucks. I think Excel does a terrible job. In fact, we're going to compare. This is the Excel Histogram Maker. Now, actually, before we do that, how would you describe, and I'll since Michael did such a good job on that, I won't pick on him again. Marin, how would you describe this histogram, the shape of it?
That be right skewed?
That would definitely be right skewed. Now, problems with it. Does anybody recognize any problems? And let me give you So, kind of remember what it looks like. What are the problems with it?
It's not labeled.
It's not labeled. Okay, what else?
It doesn't have axes.
Doesn't have what?
The axes.
The axes aren't labeled. Yeah, that's true. Okay, what
The
else?
bars aren't actually touching.
Well, they are
And
touching
there's
in this
only
case.
there's only 4 groups instead
There's
of
only
like
4
5 to 7.
groups. Yeah, instead of 5 to 7. Okay, so the thing is, if I had hundreds of pieces of data, I probably would use the Histogram Maker, but on the small data sets that we're using, it's the Excel one just doesn't work very well. So, all right, let me sort my data here. And by the way, I did that without sorting it, but I'm going to sort my data here. And we're going to make sure you guys are really good at this. Okay, so Marin, we already picked on Marin. We're going to pick on Kylie. Kylie, so how would I do make a histogram out of this data?
Just sort it into like 5 to 7 groups.
5 to 7 groups. Okay, so we go from 10 to almost 24. So what groups would you use for this?
I'd probably do like 1 to 5. 5.
Well, we start at 10, so I'd probably start at 10 though, right?
Okay, yeah. I'd probably
So
do, like,
what would
2 groups, like groups of 2.
Groups of 2. So you're saying 10 and 11?
Yeah.
Now, because this is continuous data, maybe I'll go to 11.99.
Okay.
Okay. So then 12 to 13.99, 14 to 15.99, into 17.99, 18 to 19.99. I think we're getting a lot of groups here. 20 to 21.99, 22 to 23.99. Whoops. Is that good? Oh, that covers everything. Okay. So we've got here, how many groups? 7 groups. Perfect. Okay. All right. So Kylie did that. So Keaton. Where's Keaton? Oh, there's Keaton in the bottom corner. So Keaton, what would I do next? Are you on mute?
Yeah, sorry. Is it time to make the histogram now?
Yeah, how do I do that?
Are you using Excel?
Yeah.
Wouldn't you just take the data in the groups and then have it make the graph?
No, because I already did that and I said it sucks.
Ah.
And plus, you can't use the histogram maker on the test.
That's true. I'm not really sure what you could do to because we're trying to get it to be more of a bell curve.
Well, you can't force your data to look like a bell. But what I'm asking you is, since Kylie gave you these groups, what do I do next? What's the next step?
Make a new one. Make a new graph. Not sure.
I know, but you're missing a step here. What is my next step? What do I need to do in order to make a graph? You're going to draw this on paper. What would you do next?
Make my axes. I don't know.
You need to count the frequency, right?
The frequency, that's what I was looking for. Are
Frequency.
you guys going to all miss this frequency histogram question? Because that's like the third one that's missed one today.
I think so.
Man, we probably will. You should put it on the test.
I will definitely put this on the test. So I want nobody to miss it, okay? So this is you're getting your reprieve here. Okay, so we're going to count these up. The 10s and 11s there's 6 of those. So this is my frequency distribution. Whoops. Okay. And then my 12s and 13s. We've got 14 of those. And my 14s and 15s. 14s and 15s right to there. I got 10 of those. My 16s and 17s. I've got 4 of those. My 18s and 19s. Don't have any 18s. 19s, I got 3. My 20s and 21s, I don't have any of those. My 22s and 23s, I got 3 of those. So I'm going to put a 0 here because you don't want to collapse those. And I got 3 of those, okay? So now we're going to do the grouping, or the graph that, oh, I already forgot your name. Keaton was trying to jump ahead without counting. So yes, we're going to make our bar graph with the axes. We're going to make it touch. Why does it do that? And now, by the way, does that look anything like the histogram maker that we made down here?
Mm-mm.
No, not even close. Okay. So, okay, so let's see, that was Keaton, right? So Jonathan, what would I put for a label down here? What does this represent? Are you on mute?
Yes, I certainly am on mute. Sorry about that.
Okay.
You would put the 3-year rate of return on mutual funds?
Rate of return. And what about over here?
You would put the frequency of the rates. I don't know how you would word it. Like,
yeah, so frequency is kind of a catch-all term, but what are we counting here? What do these represent?
Percentage.
These are number of what?
Percentages.
These aren't percentages.
Well, the number of. I don't really know how to. I don't know how I would word that, honestly.
Funds. Number of funds.
Oh, okay, number of funds.
Okay. And then up here, we could put in the 3-year rate of return for mutual funds. Okay. All right. So now, let's see. That was Jonathan. Jed with the cool mask. Jed, how would you describe this?
Oh, like the curve?
Yeah.
Would this
We
be
said this was right skewed before, right? So this would be what?
This is well, at least from the book, I'm actually showing that that would be a skewed right.
Yeah, right skewed as well.
Yeah.
So right skewed, you could maybe argue it was maybe bimodal because you kind of have 2 humps, right?
Yeah.
But I'd probably go, it's more skewed than it is bimodal. Okay. And don't collapse things just because you have a 0 there. You're going to want to keep that because then you might wonder if these are outliers. We'll probably get into that. Okay. All right. So are you guys feeling pretty good about histograms?
Not too complicated.
Yeah, not too complicated. All right. So remember, you guys aren't going to have to use the computer to graph these. You'll be doing it all paper and pencil. Okay. Now, I don't know why we teach you guys about stem and leaf plots, because this was back when we didn't use computers. Okay. You can think of this as kind of a text histogram. And the idea here is, okay, so you can think of these as the stem and the leaf, okay? And so as you can see here, so I've got a bunch of numbers here. 15 is the smallest. It looks like I'm in the 30, 32 is probably the highest. And so probably the easiest way to break this up is into 10s, 20s, and 30s, okay? Now in the book, I think they sort these. I don't normally care all that much. Oops, didn't mean to do that. But what I am going to do is I'm going to put a little line here on the right side. So So I've got a border here. So I've got my 10s, my 20s, and my 30s. So the first one here is 24, and so I'm going to represent that as 24. Okay. And then I'm going to represent this as a 15, 1, 5. And then I've got a 26, and a 24, and a 26, and a 26. And then I've got a 30, a 31, and a 31, and a 25, and a 23, and a 22, and a 31, and a 32. So the nice thing about this is you could do this on a piece of paper here really easily. And if you turn your head sideways, you can kind of see that this is kind of like a right skewed, you know, if you turn your head sideways, you can see this is your peak right here, and then this tail is bigger than that tail. So this would be an example of a right skewed distribution. Okay, so it's best done with pencil and paper. You don't need to draw a graph, but you just use the numbers. So you've got your stem, which is the tens digit, and the leaves you just put as the ones digit. So it seems like books like these, my point is you'll probably never use these in real life. I don't really know why we teach them to you, because when we have nice computers, we can do that. But so this will definitely be more of a test type question. So, so that's your stem and leaf plot. So any questions on that? Okay. All right.
actually,
I'm trying to remember if there's anything else I want to cover here.
I was just gonna ask really quick.
Okay.
I don't really get where you got those numbers from the stem and the leaves.
Okay, so the first one was the Acura goes 24 miles an hour, so that's 24 miles per hour.
Okay.
Okay, or miles per gallon. I mean, the Bentley Arnage gets 15 miles an hour, so that's 15. Sorry, that's 15 right there. The BMW 535 is 26, so 26.
Okay, I got you. Okay.
The Buick LaCrosse is 24.
If you only had single digit data, how would you go about that?
Yeah, it doesn't work with single digits.
What about triple?
It just doesn't work with single digits. Yeah, so, but yeah, so basically, yeah, you're looking, the easiest way, the nice thing about these are all equally sized groups. They're all groups of 10 essentially. Or, you know, if you had 110, 111, 112, maybe you'd put a 10, 11, a 12 here. And then, you know, so, whoops, so 10, 11, 12, this would be 101, this would be 111, 112, 113, etc. This would be 123, for example. So you could have a 2-digit stem instead of a 1-digit stem, and then the leaves would all be a single digit. So the idea here is you're always going to put a line here on the right side. So this is basically, this is your stem, and these are your leaves. So
in the book, it gives an example of using decimal points. So
yeah.
It uses the stem as an inferred decimal holder.
Yeah, you could do that as well. Okay. So my point is, you'll probably never use this in real life. We just show you this one time, and then you'll never see it again. Because when you can make a graph, it makes it a lot better. So anyway, so back in the old days before computers, you could do something like this on a piece of paper, and you could make a graph fairly easily. So does that make sense? Any questions? All right. Now types on different. So okay. So this is going to be so that's 2.2. Other types of graph. I'm going to cover 2.3 and 2.4 because I think they're really easy. So a line graph. line graphs, okay? Line graphs are used for data over time, okay? So for example, let's say I had January 2020 and February 2020. One of the nice things about Excel is you can drag down and it will be like, oh, you want to do this every month. And maybe we could do coronavirus cases. And so in January, we didn't have any. And in February, we had 10. And then in March, we had 100. And then in April, we had 500. And May, we had 550 and 600 and 700 and 1,000 and whoops. Now we're in August and we're trying to get a hold of this thing and we're going to get 800 and 600 and 400 and then 200. Okay. So the idea is we're using this to track data over time. So if I've got a month here, so if I asked you what type of a graph you would use, you would hopefully say this would be a line graph because we're tracking data over time. And so if I just draw a little line graph here, I could probably still add some axis titles here and we could put number of cases. And these are coronavirus cases by month. And that's pretty self-explanatory. Maybe I'll get rid of that. Okay. So the idea here is, and I know we've talked about skew before, but we're not going to talk about skew. Skew doesn't apply to line graphs. Okay. So we've got an upward trend through August and then downward. Boy, that's like a straight line downward. Okay, so when I ask you to describe these graphs, we're trying to see what is the trend. So we're definitely an upward trend to August and then a downward trend. So yeah, so the line graphs you're going to use for time data. So and these could be years, 1990, 1990. Oops, I guess I can't do that anymore. I have to change it back. But anyway, so line graphs you're going to use for trends. And that's the main thing. I will mention, since somebody mentioned the main thing is over time. I will say this also, line graphs are used for what we call survival analysis. You can actually take a class in survival analysis when you're trying to track, AIDS cases or something that kills people. Sometimes they will use line graphs to track that as well. But once again, that's used for data over time. So how many people are still alive after a treatment or something. So so anyway, that's typically how we're going to use line graphs, is to track data over time. And then finally, now one of the things that I could do, so that's the end of 2.3, and then 2.4 talks about misrepresenting data. Okay. So the ways that I could misrepresent data, maybe I don't want to show this nice steep thing, and so maybe I'll just drag it out here, and then you can say, look, it's just gradually increasing. Or maybe I want to make it look worse and say, oh, well, I'll just drag it down this way. Look how steep everything is. So you can distort your data. Also, another way to distort your data, instead of starting at 0, maybe I will start at, say, 400. And then it looks like, look, there are no cases in December or February or March. And so, so distorting your scale can be another way. So especially if you're tracking things over time, you generally do want to start things at 0. Now, I do have to be careful here, because sometimes people, we don't have any returns here that start lower than 10. So there isn't any reason to start my x-axis at 0, because the lowest I have is 10. But in this case, I actually do have some zeros and some small numbers here, and so I do want to start those at 0. So anyway, you kind of have to be a little bit careful with that. Now, another thing that I can show you here that you should never use are what we call pictograms. Pictographs or okay. Now, USA Today. So these are some things. I used to teach a math for elementary school teachers, and they love these little cutesy smiley faces and pencils and whatever here. And I'm like, oh, and I love the half apples here. That's just a terrible way to draw a graph. So never do anything like this. USA Today graphs. So they love to do little cute artsy things like, oh, look at this guy's got a cast, and they make a bar graph out of it. Okay, don't ever do that. USA Today, I will grant it, they have some of the coolest, artsiest graphs, but they're also, the problem is you can distort your data. Oh, McDonald's. Okay, so this is another good one. Okay, we're going to really distort our data with making the logos bigger and smaller. Taco Bell compared to McDonald's, and everything's huge. Also, you should never do 3D graphs. Okay, so it distorts it. And these dumb pencils here. Anyway, so USA Today is the best example of very artsy graphs that are terrible. And look, these aren't even straight dollars here. So, so in my class, as far as misleading graphs, okay, no 3D. Don't use pictograms or pictographs, either way. Don't distort your data. And there are a couple ways you can distort it. You can either distort it vertically or horizontally, or you can not start at 0. I could also shrink this so that it looks really steep or something. So anyway, I think we're out of time. So any questions you guys have before I let you go?
Yes, I have a question.
Okay.
In 2.3, it talks about class midpoints, frequency polygons, and ogives. Are you expecting us to know what those are and be able to construct those graphs as well?
Yeah, so I always skip that because an ogive is basically turning a histogram into a line graph.
Mm-hmm.
Which is sort of helpful, but you'll never see us use that word again after this section. So I'm not going to worry about it. That's the short answer.
No, we don't either. Got it.
Yeah, don't worry too much about the ogive. Other than the ogive is just basically it's a line graph for a histogram.
Okay.
So you're going to pick the midpoint of all those. So this would be 11 would be the midpoint, and 13, etc. And you just connect it with a line graph, but you'll never see that again. Okay, good question. Any others?
One quick question. I saw when I first started the class that there's a sheet that shows us all the assigned homework problems, but when I was looking for it yesterday, I couldn't find it. Where's that located?
That's under the syllabus.
Oh, it's in the syllabus. Okay.
Yeah. So if you've got your syllabus, so if you want to just print that out and put it in your book, that's great. Hopefully everybody has their book. I think there's only one person that doesn't have their book. So.
Quick comment. I show up as Alexis Fulkerson on here. It's Emily Fulkerson. I'm just using my sister's laptop.
So you got really garbled there. Something about Emily Fulkerson.
So on the screen, it shows me as Alexis Fulkerson. I'm Emily Fulkerson. I'm just using my sister's laptop.
Oh, okay. So you're having an identity crisis. All right, thanks. Okay. So the quiz will be on 3 sections because they're pretty quick, I think. And I won't force you to draw anything on the quiz tomorrow, but I will force you to draw on the test. So this is kind of where the quizzes and the tests, the quizzes probably on this chapter aren't as representative as they will be on the test. So the test will be more like your homework than the quizzes. Okay. All right, I'll let you guys go. See you all tomorrow. Quiz will be on all 3 of those sections, 2.2 through 2.4. So have a good one.
Thank you.
Thank you.
Thank you.